Alright, what's going on, everybody? Today we're going to be doing another LeetCode problem. This one is called valid parentheses. So for this problem, we're given a string S containing just the characters open parenthesis, close parenthesis, open curly brace, close curly brace, open bracket, close bracket. And they want us to determine if the input string is valid. So we know the input string is valid if the open brackets are closed by the same type of brackets, the open brackets are closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So you can kind of imagine, it's kind of like a big mathematical expression. Imagine you had to like alternate parentheses. They have to be closed and open in the right order. So like this would be valid, but if you did something like this, that would not be valid, because notice how they're not being open and closed in the correct order. They're kind of overlapping. So anyways, let's look at some of the IO that they provided to see more what's going on. So we have an input S here. That's our input string, and we have an open parenthesis and a closed parenthesis. We're going to be returning a Boolean value depending on whether or not the string is valid. This one is valid because we have an open parenthesis and it's closed by the corresponding type. For the next example, we can see that this string is also valid because each parenthesis is closed by the correct type, and they're all closed in a valid order. This one is invalid because you can see we have an open parenthesis here and it's never closed by the corresponding parentheses. We also have another closed bracket here. This one just doesn't work. False. It's an invalid case. Now for constraints, we know that our string is going to at least have one element in it, so we don't have to deal with the case of an empty string. Also, we can see that S is going to only have those 6 characters. So there's really, if you imagine writing an algorithm for this, as we loop through the string, we really only have these 6 cases to check. There's 6 characters we can see, and then we act accordingly. So let's get into the code here for the solution. So the optimal solution is going to be, we're going to use a stack for this problem. Many problems that deal with opening and or checking valid parentheses deal with stacks. So we're going to use a stack for this problem, and using a stack, our time complexity will be big O of n, where n is the size of the string, because potentially we need to check every element in the string if we don't exit before looking through the whole string. So if the whole string was valid, we could potentially be checking through the entire string there, giving us worst case linear time. And then for the space complexity, it's going to also be linear because we're going to use a stack, and the stack could potentially have in elements. The stack will only really be storing the open parenthesis, but if you imagine you have a string that wasn't valid and it was completely full of open parenthesis, we'd have to add all of those. It's kind of hard to see because I haven't actually written the algorithm yet, so let me write the algorithm so you can get a better idea of those time complexities and the space complexity to see how it's working. So the first thing we need for our algorithm is just a stack of chars. Those will store our open parentheses. And then we also need, that's actually all we need for the stack. So the next thing we can do, or in terms of data structures, so the next thing we can do is just loop through our input string. So I'll use a C++ style loop here. So for every character C in the input string S, the first thing we want to do is just check if we have an open parenthesis. And I like checking for the open parenthesis first because we're always going to be welcoming open parenthesis into the stack, no matter what. So if C is an open parenthesis, or if it's an open curly brace, or if it's an open bracket, then we can just go ahead and add it to the stack. And to put something on top of a stack in C++, we're going to use the push method. So it's just push and then we're going to push that open character that we see on top of the stack there. Now, the next thing we need to do is, remember, there's only the possibility that there's these 6 characters. So, we've already handled the case where we see the open one. So if we get to this part of the control path, we know that we're looking at a closed parenthesis. So if we see a closed parenthesis, the first thing we do is check if the stack is empty. Because if the stack is empty and you see a closed parenthesis, there's no possible parenthesis it can be closing. So if the stack is empty and we're at a closed parenthesis, so if the stack is empty, we can just return false, because we know that's going to be an invalid scenario there. And next up, we need to make sure the given closed parenthesis is closing the open parenthesis of the corresponding type. So the code for that is, we're just going to ensure we have, so let's say we have a regular closed parenthesis there. We need to make sure that the element at the top of the stack, and that's actually st, so st.top, to access that top element, we want to make sure it corresponds. So, and if it does, then we can do st, or let's actually do that on a new line, st.pop, because we're done with these 2 corresponding parentheses, and we know that's valid, so we get rid of it and then move on. Now, there's 3 other cases here. The way I'm going to do this is I'm going to wrap this in parenthesis. So it's like, what are the other cases? Well, it's just the other cases are simply the 3 other, or the 2 other types of parentheses. So I'm just going to copy this, and this is going to be, actually I'm going to add an or in here, right? Because there's 3 different cases there. So, and then I'll do it like that, and hopefully this is clear enough what's going on here. But we're going to do the same thing for the other 2 types of parenthesis. So for the closed curly brace, the closed bracket, open curly brace, open bracket, just making sure those are corresponding properly. And then otherwise, one of these cases must be true in order for the input string to be valid. If we don't have a corresponding corresponding parentheses here, we can return false, because we know we have mismatching parenthesis, so we know it's going to be invalid. So we have to return false if one of these cases doesn't happen when we see some closed parenthesis. So that's pretty much it for the looping. Now, before we can just return true, there's one more case here to consider. So we need to make sure the stack is empty at this point. So imagine there are still elements in the stack. What does that mean? It means we have open parentheses that have not been closed, and that's invalid. So instead of just returning true here, we can actually use a ternary statement. So let's return true if stack.empty, then we can return true. Otherwise, we return false, because the stack must be empty at the end of this. So that's about it for the code here. I'm going to go ahead and run this. And you can see we get 3 milliseconds. So I'm just going to go ahead and submit. And to reiterate for the time and space complexity, so beats 100% with runtime, 60% with memory. This is the optimal solution. So again, time complexity is linear because we're at most iterating through every string. Well, not at most. I mean, you could see here for char CNS, we're going to be iterating through every element in the input string. So linear time, and then for our space complexity, we know that's also linear because at most we're going to be pushing every character to the stack there if every character in the string is an open parenthesis, some form of open parenthesis. So hopefully this video helps you understand this problem more and gives you insight on a possible solution for it. If it does, please leave a like and subscribe, and I'll see you guys in the next piece.